before we do any more coding, what I want to do is take a look at the situation. Let's no, that's fine. We'll keep the shell open. Let's just zoom away a little bit. Let's imagine we've got 3/5, and we know that that can't be reduced any further. So let's take a look at what the algorithm does with it. So A is going to equal 3, B is going to equal 5, and then we produce A mod B, which is 3. It's not our 0, so we swap them round. So A is going to equal whatever B was, which is 5, and B is going to equal the blue value, which is 3. And again, we perform A mod B, which is now 2. Again, not 0, so we're going to do it again. So A equals whatever B was, which was 3. B is going to equal whatever the blue value was, which is 2, and we're going to do A mod B. And we get 1. Still not 0, so we are going to swap them around again. So A is going to be whatever B was, which is 2, and B is going to be the blue value, which is 1, and we perform A mod B, and we get 0, and then B is going to be our returned value. Now that is going to happen every time that we have a fraction that cannot reduce to, that there's no common factor involved. It's always going to finish off with the value 1. And I needed to mention that because we're going to make use of that in our code. So if I close down the shell, and let's get this back. What I want to do now is go into the fraction, because I've got all my reductions here, like scaling and reductions, and I can find a highest common factor, but I actually want to sort of work out what the lowest form is. I want a function to give me the lowest form. So in here I'm going to create a function, public void. It's not static because I'm not going to be using it from anywhere else. It's internal. It could be protected. Public void to lowest form. So what it's going to do is take whatever the x and y values are of the actual fraction itself, and it's going to just reduce them to the lowest form using the methods in point. So let's start off. I need a result, because I need to find the highest common factor and store that. So int result, and I'm going to set that to the highest common factor of, here's the important part, get the x value of the fraction for A, and get the y value of the fraction for the B part. Now all I need to do is check whether the value is 1. If you remember, we got 1 if we could not reduce the fraction. In other words, 1 was the highest common factor of both numbers. So we're going to check that. If the result is not equal to 1, so what we're saying here is if it is equal to 1, we're not going to do anything. We can't reduce it because it's already in its lowest form. However, if it isn't equal to 1, the highest factor, we're going to divide each part by that. So we're going to use one of our methods that we've used before up here with the set xy. So we're going to set both the x and the y at the same time by typing set xy, and what we're going to do is we're going to divide the x value by the result and the y value by the result. So we do that by typing get x. So that gets us our x value, and I can divide that by result. And So that's the new x value. I can do the y value, the same, get the y value, and divide that by result. And that should give me my fraction in its lowest form. Just one more thing to do, because when I initially set my fraction, if I typed in 2/4, it's going to set 2/4, 2 and 4. But it's not going to change that to be its lowest form. It's only going to be in its lowest form when I call lowest form. So that might be the result of an addition or a subtraction or so forth. But I want it to happen when I set up my fraction to begin with. So even the result of maths with fractions, I'm going to reduce. I'm also going to reduce it if I type in some strange sort of fraction that isn't in its lowest form. So all I need to do here is just to call to lowest form. I don't need to bother passing any arguments or anything else like that. That is sufficient, to lowest form. So it's going to set n and d, let's say 2/4, and then go to lowest form. It's going to run through the highest common factor, and it's going to reduce it and reduce the x and y values that are stored in the fraction. So all I've got to do is sort of test it. If we remember last time on data types when we tried it, fraction 2/4, we got 2/4. I'm expecting 1/2 now. So if I run the program, fingers crossed, there we go. So I've got a fraction of 1/2. Let's just test that one that we did before when we had 48 1/80ths. Now we remember that when we did that, that gave us a highest common factor of 12, which reduced that fraction to 4/15. So let's see if we have that working. Away we go, and 4/15 just as required. Last one to test is, well, what happens if we do 3/5? In other words, it already is in its lowest form. Will that work? And there we go, 3/5. So now we can set up a new fraction. Doesn't matter what value we get, what value we give it, it's always going to return the fraction in its lowest form. Okay, so now we've got some methods which are going to help us to add two fractions together and then convert it to its lowest form. The same with the other operations. So we'll do that in further videos.